So we're dealing with a 2018 Toyota Camry. It's got a 2.5 engine in there. This simply just has a common water pump problem. Let me show you that code. So this is the code we're dealing with. P26CB71. Ignore the top one because that was me just screwing around. I'm not familiar with this system, but it's basic. I'm gonna consider it basic because it's got power, grounds, control, and feedback. So sort of like ignition circuit for Toyota. You have like an ignition confirmation that will confirm that the circuit's operating properly. So what's going in should be able to come out. That's the ultimate goal of this video, is just to see what it looks like compared with the old one and put the new one on there and see if we got some change in data. Now I'm going to tell you what's going on here. The check engine light come on and it requested that the lady pull over for and I'm not sure if it went into a limp home mode, but she eventually got it towed here. So here we are. I've seen some people on the internet replace the water pump, but I want to extract more data. The girl that I'm with now, she has this engine in her car, so I need to become familiar with it and just kind of keep my testing abilities up to par. So again, I just want to know what the data look like coming out and going in. So we got basic powers and grounds. Let me show you that. How long I've been talking. Let's go ahead and just get the camera set up and jump right on into. So pretty much I'm going to test this circuit with the key on, engine off, and I'm going to at least at minimum put up a wiring diagram of what we're ultimately testing so you can kind of get an idea. But pretty much these outside pins are either going to be powers or grounds, and I'm going to show you that with the Power Probe 4. I think this is the Power Probe 4. And the inside ones are going to be the computer control, whether it's the computer control to activate the water pump or the feedback. So we're going to determine which one of those through the process of deduction. But I do know for a fact, looking at the wiring diagram, the green wire is going to be the control wire and the black wire is going to be the confirmation wire. So let's check powers and ground for some basic info, and then we'll see what the wires look like with the Power Probe testing both circuits. So the circuit works, it's just the feedback is inadequate in generating check engine light. My assumption is this water pump is pretty much freewheeling and not circulating, and I don't know until we pull the water pump out and test that. Key is on, engine off. Now you're going to get a different reading likely because of the circuit not being plugged in, but this is just with the system unplugged. What do we got here? Oh, this, I'm on frequency. Let me take that off. Voltage DC. I'm not sure if they will see that, but so that's a power. Here's another power. Ground and ground. So facing the connector, we have ground here, power over here. So let's check the centers because these are the main ones I want. So we have 0.02 and we have 11.6. So what this is likely going to be our control wire, our green wire, when I pull this cover off at the top here, because this right here is what sends a default signal to the water pump based off the service information, and it's not going to activate it, but it's just like a I'm gonna call it bias voltage for like testing measures. So let me see if I can just, this is probably not a good idea. I don't want to break it. Kind of making me nervous using my device to pull it off, but things that are not supposed to be hammers are going to be hammers. Things that are not supposed to be designated tools are going to be designated tools. So we'll pull that off. So logically, let's see if I was right. I was probably wrong. Let me see here. Okay, so this is the black wire actually. So the black wire maybe
our wire for signal. I swear it was supposed to be the green here, but then again, it's not plugged in, so the circuit's not going to work normal. That's why I'm gonna plug it in and recheck and back test myself here, because one of these wires are not having good output, and we should see a square wave on both. And I'm going to activate the water pump and monitor both of those, the green and the black wire. So we're going to monitor both of those. Let me get my scanner, show you some scan information, and then we'll check the oscilloscope.
So I was going to go into live data, but let's go straight into active tests, and I'm going to isolate the PIDs I need to justify what I'm doing. I'm going to get, I need, where's that water pump control? Did I overlook it? Okay. Water pump speed, target speed. I think we'll be fine with that. All right, so the plan, what's supposed to happen is this water pump speed, this is normal. This is just that wire that we looked at, the black wire. So that should be our confirmation wire. That's just a signal integrity check. So that, being that that's a signal integrity check, that green wire is going to be the activation wire for the computer system and that module inside of there to activate the water pump. So we have a target speed and the actual speed here. This should be 3,000 because I'm commanded it to be 3,000. The target speed should be 3,000. This should reflect theoretically. So this is normal for integrity check. Ignore that. Even the service information states it's supposed to be around 160 RPM. I'm going to command it to 3,000. 3,000. This should reflect. So, and it's not reflecting. So let's see. The water pump was activating before. Show you another thing I noticed. It's not even moving the water. So the coolant's not moving. This is not changing. I want to check that black wire. I want to check both wires. We're gonna hook up the scope to both the green and the black, and then we're gonna see the difference with the activation wire. Us giving it commanded to 3,000 RPM, see how the pulse width modulated signal work with that, and then the feedback wire. And then we're going to tap on it and see if it makes any big difference or not. I don't know how this system works specifically, how it extracts the RPM. I don't know if it utilizes a sensor on the impeller. I don't know. I think it's worth looking into, but I will say the good thing is, just to be topical, we have information that is going in, and we have a monitor that is supposed to detect the information going out. So once I pull the water pump off, I can activate the water pump and see if it's rotating or not. It could be a load thing, because that water has resistance. It's gonna, and that shaft probably broke. It's not gonna turn that impeller. So I'm probed in. Let me go right there. There we go. The black is going to be the black. That's our confirmation circuit, and then the blue is going to be on the green, which is the control circuit. So let me show you this here. I'm on a 1 second time base, and I have the 20 volt scale here. Remember, it was by the factory, the manufacturer. It had an integrity test of 4 hertz. So if we do the scale here on the 1 second time base, we can see our 4 hertz here. 1, 2, 3, and 4. So that's correct. The biggest thing is when we control the green trace, which is going to be the activating wire, does the channel A, or the does that confirmation wire change? So let's go ahead and keep this going here. We're going to exit out and go into our active test. Water pump is running. And here we are. Let's close it off there. So we're not seeing the same PWM on that confirmation wire. It's still the same. Still the same. Oh gosh, let me see if I can. That's what I wanted. I kept it at the same 1 second. Are we still on 1 second? Yeah, we're still on 1 second. So it's just on and off. It's just toggling the circuit now. So it's off and then on. Yeah, it just, this active test is just toggling it. So it's not matching, so the computer is telling it to work and we're not getting any feedback of it performing any work. So it's not doing anything. We just don't have any confirmation coming out that water pump. So however it decides to determine the speed, it's not doing anything. I don't know the hertz for the input, but I'd imagine with 3,000 RPM, this is going to be the frequency, obviously, because we see it, and it should match. So we should get an overlapping waveform, and we don't have that. So this is just a clear indication. Simply, the pump needs to be replaced. So if I do have this issue in the future, we know the values. We need 12 volts on one outer edge, we need ground on the inner, and then we need to see that 4 hertz on the black wire. And if we go into the command feature to control the circuit for 3,000 RPM, we should be able to see reflection on the confirmation side, which is going to be that black wire. So right now, I simply just need to replace the water pump. When I get the water pump, the new one, we're just going to hook that up when I get everything installed and back test this and see what it looks like. So at the moment, what we're going to do, we're going to try hitting the water pump to see if it makes any notable change. I'm going to use a 22 millimeter Pittsburgh wrench, and I'm going to tap on it and see if that orange trace makes any difference. Nope. Nothing. So the new water pump came in. This is the old one, obviously. I want to show you what that looks like on the inside. This had locked up, actually. So this is where the thermostat go. And I took a pick and tried to move the impeller in it, and it's locked up. So I don't want to see if the shaft actually just rotates before we install the new one, and then check the output data and see if it looks different from before. I just want to activate it and see what's going on with it. I think that the drive shaft forward is just freewheeling. It's gonna pick all data. So we're gonna look inside of there. Let's just I guess I was wrong. I mean, it's not moving, but I thought the shaft in the middle there that connects them will be moving. That's interesting. I'm curious. I want to pull the back of it off and see what it looks like. Am I able to just knock the center out? Let me try that. It looks like I can just take a punch and just push it all the way out. So it's a seal here. Here's the driving motor for the impeller. Well, it moves now, so it's a possibility that it might work now. I'm going to hit the activation button on the scan tool. Oh wow, so it stays running constant if it worked normal. So what we were looking on the oscilloscope, it was pulsating because it detected a load and discontinued activation. So that's obviously it's still providing a pulse. And being that there's probably having some feedback, it's going to allow it to continue because it didn't have that feedback from before. We got the water pump installed, very simple replacement. If I recall, I think the labor time is supposed to be 1.8 hours. So let me show you what the coolant looks like when you activate it. So if you can determine if there's any movement or not from the pump in conjunction with the code. So I'm pressing the button now. So we get some agitation there. I'm pretty sure it'll be different too if the air was out the system. Let me shut it down. We can see that it did calm down from that relief valve there. That I guess I don't know if that's for like aeration to get air out the system, but I'd imagine. But that return line. Hit it again. You can see there's some movement. Deactivate it. Nothing really changed. I'm gonna hit it again. We can see like a little flicker of movement. So let's go ahead and hook up with the oscilloscope and let's see what this data looked like after the fact, and we'll be good to go.
So the probes are back hooked up. The black is on the black. That's gonna be our confirmation wire, the feedback wire, and the blue is on the green wire, which is going to be the activation wire from the PCM. So the PCM is going to tell that green wire to work. The black wire should be able to extract that information and reflect the input on the output. So just like the IGF, something like that. So let's see. So we're on the same time base, 20 volt scale. These are making 12 volt square waves. That information is coming from that confirmation black wire, so that's that reference signal. So what we're going to do, we're going to go back to the active test, hit our 3000 RPM signal. So now our water pump speed should reflect the target speed. And it is. So I told it to do 3000. Target speed is now 3000 and it's around 3000 RPM. Let's see if the oscilloscope is doing the same thing. And it is in fact doing the same thing. So we can see here our 1 second time frame has definitely changed. So we don't see that 4 hertz anymore on the orange trace because it's reflecting what the computer is expecting. So let's enhance that, see what that looks like. So I want to put in the measurement on here for hertz, and our 4 would have been 4 hertz on the channel A has went to 75, and the computer input for command state is at a 25 hertz. So that's what that would look like from the 1 second division. So it should have been approximately 25 pulses on the green and 75 between from 1 second to window. So basically, let me see if I can get this back. So basically from approximately here to here, it's going to be 75 red pulses and 35 green pulses. So we should be pretty familiar with that when it comes to the frequency and the waveform. So this is pretty interesting. Even though the code knows what's going on and know that, hey, I'm not seeing that data there, I'm broken, check me out. And this is what the PCM is likely detecting when it triggers that code that we were looking at originally. We saw that the water pump was locked up. It wasn't getting any feedback. We saw what it looked like before, with it broken. We saw it broken, and we saw what the information looked like with it fixed. So assuming that, you know, you're one of those guys that have like that curiosity and want to test things and don't want to pull everything off, well, we're going to have to test circuit integrity anyway, because what if there was a broken wire from in there somewhere? We wouldn't have known. We could see that the computer can control it, but it doesn't sense that output. So it's a possibility that that black wire may have been broken somewhere in the frame or wherever the wiring harness goes to. It's a possibility it may have had a control issue. So we now know what needs to happen when we diagnose this. So hopefully this information helped. I'm gonna test drive this car and give it back to this lady, but I know for a fact this is 100% fixed. Confirmation, like before, after, I saw everything. So I have no doubts in my mind. I don't know how everybody else is gonna feel about it, if they're comfortable just throwing a part at it, but in this particular case, I have 100% conviction that I replaced this part and it's 100% fixed, so it can go right on out the door and I have a peace of mind. The brand I did use was the ASIN brand for the thermostat and the water pump. So these are factory Honda stuff, if I recall properly. So we're in good shape with that. So we got a good brand. We tested everything, so we're good on that end. I can sleep with a peace of mind now. But if anything happened, I'll definitely update. Hit that link, subscribe to the channel, stay informed how the originals gonna work. See you on the next one.